Hello everyone, welcome to the channel. Application of stack. Stack is a data structure that is based on the principle of LIFO, means the last in first out, means the element pushed into the stack in the last will be popped out very first. Okay, we can access the element of a stack using the top method. Top returns the top element of the stack. Okay, there are various applications of stack, but I have listed a few of them. First is reverse of the stack, undo redo, recursion, function call stack, evaluation of arithmetic expressions. Okay, first is reversing of data. If we have some data set, we can have an integer data set or a string data set or any type of data set. We can reverse that data set. Okay, in case of integer data set, we can reverse a data set or an array. Here we have integer array. We can reverse it. First, here our array has size of 5 and it has an element 1 2 3 and 3 4 and 5. Okay, we will push each element one by one into the stack. Here 1 is pushed into the stack, after that 2 3 4 and 5. After that we will pop out each element and print one by one. 5 will be printed, after that 4, after that 3, after that 2, after that 1. You can see our array is reversed. Okay, we can store it in another array that is called a reverse array as well. Okay, reverse a string. We can reverse a string in the same manner as we did in the array. We will push one by one each character of the string and we will pop out one by one. Okay, next one is undo and redo operation. Okay, let me show you. Wait, in any editor, undo and redo operation is very important, and it is implemented using stack. Let me show you in this editor. In this board, I have a editor embedded with it. Okay, here I'm writing A, B, C, D. Okay, if we undo, we can go back to previous states. Okay, D will be deleted, after that C will be deleted, after that B, after that A. If we perform redo operation, it will be again written. A is written, B is written, C is written, and D is written. How it can perform? It can be performed using the stack. In the stack, first D will be, when we press undo button, D will be pushed into the stack, after that C, after that V, after that A. Okay, and when we press the redo button, A will be popped out and it will be placed at the same position. Okay, after that B, after that C, after that D. Okay, this is how undo and redo operation is performed. Okay, it is very useful and it is used in any type of editor. If you see in your VS Code, you press Ctrl Z, it will again write the redo operation. It will perform redo operation. Okay, By pressing Ctrl plus Z, we can get the deleted text. Okay. Here, next application is recursion. I have written a factorial function of a factorial by using recursion. If you see in the code of function, when it has a function has a parameter, one parameter, that is integer num, integer type num, and when num is 0, our function will return 1, and when num is 1, our function will return 1. Both are base cases. Okay, and this is the exact solution of this factorial problem. Num into factorial of function of num minus 1. Okay, we are it returns we are writing the solution in terms of the given problem. Okay, that is the recursion. If we have to find factorial 4, we will pass 4 into the function, and it will return 4 into f of num minus 3, 4 minus 1, num minus 1, 4 minus 1, that is 3. 4 into f of 3 will be pushed into the stack. After that, f of 3 will be called. When we call f of 3, our function will return 3 into f of 3 minus 1, that is 2. Then this 3 into f of 2 will be pushed. After that, 2 into f of 1 will be pushed. After that, when we call f1, f of 1, it will return 1. 1 will be pushed, and we will pop back 1 by 1 at the end. When we pop back here in the above stacks, in the above example, you can see here, from here to here, we have pushed into the stack. Now we will pop out the element of a stack. Here one will be popped out, and it will returned data of 1 in place of f of 1. Now here the value will be 2, and 2 will be returned here. It will be popped out. Okay, when 3 into 2 will be 6, and after that 6 will be returned, and it will be popped out. Okay, at the end 4 into, now at the end of the operation, 24 will be returned. That is the factorial of 4. Okay, at the end our stack will be empty. Okay, the last 4 into f of 3 will be, value of 4 into f of 3 is 24, and 24 will be popped out from the stack. Okay, here I have shown you how recursion is performed by using a stack. We can say recursion is performed by using a stack in the background. Okay, here you can see this recursion is also part of the function call stack. Okay, it is another type of application of a stack. Here it is a function call stack. This is a stack layout. It has return address, context of calling routines, input parameters, output values, subroutines, local variables. Okay, when we call a function, these routines, these values are pushed into the stack, and we will pop out after this. We will pop out each one by one after the function call. Okay. Next is evaluation of arithmetic expressions. What are they? We have three types of notation in the arithmetic. In our primary schools, uh, back to the primary school, we have a we have been taught that this is a plus b. What is a plus b? If we have to add two numbers like 2 plus 3, we have to we perform addition operation, and the store the addition will be 5. 2 plus 3 will be 5. Plus is uh, plus is an operator, and these 2 and 3 are operands. In case of a plus b, operands are a and b, and operator is plus. Plus is a binary operator. Uh, mm, as it is adding two numbers, it is taking two inputs. Uh, that's why it is a binary operator. Okay. After the addition, after the addition, the result will be stored in a variable. Okay. Here we will see about notation. What are the notation? There are three types of notations: prefix, infix, and postfix. What is the prefix? When operator is placed the operand before the operands. Okay, that is called prefix notation. Here operands are a and b, and operator is plus. We put plus after that operand 1 and operand 2. That is called prefix notation. Okay. In infix notation, operand 1, operator, and operator 2. Okay, means operator is placed between the between two operands. Okay, operand 1 and operand 2. Here we can say infix is a plus b. Okay, postfix operator is placed after the operands. Okay, here we have two operands a and b after the plus, after operator is placed. Okay, a b plus is postfix notation, and a plus b is infix notation, and plus ab is prefix notation. Okay, when we have to evaluate certain expression, arithmetic expression, we have to convert into infix notation so that we can easily evaluate. If we have 2 plus 3 and this type of operation we have to perform, then it is in the infix notation. If we have a prefix notation, if we have used prefix notation, means let me write 2 3. Okay, we cannot evaluate this type of operation. Okay, we cannot evaluate prefix and postfix notations. We have to convert it into infix notations. Okay, after that evaluation is done. Okay, these are we can convert prefix to infix, infix to postfix, postfix to infix by using a stack. Here a stack is used, and we can easily perform these operations. Okay, these uh, these are the applications of a stack. Okay, hope you understand the applications of a stack. If you understand the concept, like my video, share with your friends, and subscribe my channel. Thank you guys. Thanks for watching. Happy coding.